Welcome to our video abstract. In this paper, we presented a localization algorithm for GNSS jamming events. This research is motivated by this real-world jamming event happened in 2022 in Denver area. And in the end, we cross-validated our localization algorithm's output with the actual location of jammer from this source. And it took FTC about 33 hours to localize the source. The reason for that is because ground-based localization methods is limited by the launch site. And therefore, we propose using ADS-B data. It's data collected from aircraft. ADS-B system is shown here as an example. It automatically broadcasts GNSS-derived position information to the surrounding environments. And because we're collecting that GPS information from high altitude, it provides a coverage of wide area. And most importantly, because we're collecting from multiple aircraft, it provides cross-sourced information. The limitation of using ADS-B is that it doesn't provide direct information from GPS receivers, such as silver node and AGC, which is commonly used for jamming detection. So we rely on an integrity level indicator that comes with the ADS-B message called NIC. The smaller NIC value is means the worse quality of the received GPS signal on the aircraft. Here's an example of how ADS-B data looks like during the normal day on the left-hand side and during the jamming events on the right-hand side. And you can see how the NIC value starts to drop when I encounter jamming. And our localization algorithm contains two main steps. Step one is given a aircraft reported position and its corresponding NIC value, we estimated what's the amount of received jamming power on the aircraft at that position. And in the paper, we present details of how we set up the experiment, how we figure out the relation between NIC and amount of received jamming power. Step two is then given any assumed jammer location, we then calculate what's the predicted amount of jamming power received at the same location of that reported position point. And by comparing the measurements and predictions from all the aircraft's positions, then whichever the jammer state that provides us the minimum amount of residuals is the most likely jammer state. And here's the results. So on the left side is the residual plot. Red is the smallest residual, and we identified the global minimum location within 0.1 degrees of the actual position. And on the right-hand side, we're providing a 95% confidence interval bound, which has a radius of 10 kilometers. If you're interested in this algorithm, please check out our paper. We also encourage you to check out our website, which we provide daily worldwide jamming and spoofing detection and localization. And the jamming localization algorithm is what we are showing here in this paper. Thank you.